Have you ever found yourself just kind of staring at the last slice of pizza and wondering, what's the geometry of all this? Well, today we are diving deep into the world of circles. We're going to go from the absolute basics of what even makes a slice, all the way to solving some real-world problems you probably see every day. Let's get right into it.
I mean, it's a question you might not think about all the time, but the math behind it is everywhere. When you're looking at a slice of pizza or a piece of pie, you are literally looking at a classic geometry problem. And today, we're going to give you the exact tools you need to solve it.
So here's our game plan for today. We're going to start with the absolute basics, the building blocks. Then we'll put together a toolkit of some really essential formulas. After that, we'll use those tools to solve what I'm calling the segment puzzle, put our new skills to the test with a real example, and finally, we'll see where these shapes are hiding out in the world all around you. Okay, first things first. Before we can start crunching any numbers, we've got to make sure we're all speaking the same language, Getting these basic definitions right is absolutely the key to unlocking everything else that follows.
So, let's meet our first piece of the puzzle, the sector. Now, the official definition is it's the area closed in by two radii. Those are the lines from the center to the edge, and the curvy bit, the arc that connects them. But honestly, the easiest way to remember it is it's a slice of pizza. That's it.
And think about this. For every slice you take, there's the rest of the pizza left behind, right? Well, that small slice is called the minor sector, and the bigger part that's left over is the major sector. Now, most of the time when people just say sector, they're talking about the smaller, minor one.
All right, our second piece is called the segment. This is the area between a chord, and a chord is just a straight line connecting 2 points on the circle's edge, and the arc. A really great way to picture this, it's that part of your pizza slice that's just the crust.
All right, with our definitions down, it is time to build our toolkit. We're officially moving from what is it to how do we measure it. And trust me, these are the core formulas you are going to need.
So how do we get this formula? It's not magic, it's actually super logical. We all know a full circle is 360 degrees and has an area of pi times the radius squared. Simple enough. So to find the area of just a tiny 1-degree slice, we just divide that total area by 360. Makes sense, right? From there, to find the area for any angle, we'll just call it theta. We multiply that little 1-degree area by whatever our angle is. It all just builds on itself.
And boom, here it is. This is the key takeaway. The area of a sector is just the fraction of the circle it represents. That's theta over 360 multiplied by the circle's total area. This is the first major tool for our kit. Don't forget it.
And you know what's really cool? The exact same logic works for finding the length of the arc, the curved, crusty edge of the sector. You take that same fraction, theta over 360, but this time you multiply it by the circle's total circumference, which is 2 times pi times the radius. Same idea, different measurement.
Okay, let's go back and tackle the segment, that crust-only piece. Now you might be thinking, oh no, here comes another complex formula. But actually, the solution is way more clever. It's a puzzle that we can solve with the pieces we already have.
Check this out. This is the elegant solution I was talking about. To find the area of that crusty segment, you first find the area of the entire sector, the whole slice, and then you just subtract the area of the triangle inside of it. What's left over is the segment. It's such a simple, beautiful piece of logic.
Theory is great and all, but let's make this stuff real. We're going to walk through an example step by step to see exactly how to use our new segment formula in the wild.
So here's our challenge. We've got a circle with a radius of 21 centimeters, and the segment we care about is formed by a chord that creates a 120-degree angle back at the center. So how in the world do we find its area?
First up, we calculate the area of the whole sector. We use our formula, right? So that's 120 over 360 times pi times 21 squared, which gives us 462 square centimeters. Okay, step 1, done.
All right, step 2 is finding the area of that triangle that's sitting inside the sector. Now, since we know 2 of its sides, the radii, and the angle between them, we can use a little bit of trigonometry to find its area. And that comes out to about 189.97 square centimeters.
And now for the final super simple step. We take the sector's area and subtract the triangle's area. So 462 minus 189.97 gives us our final answer, 272.03 square centimeters. And just like that, puzzle solved.
So why does any of this matter? I mean, who cares, right?
Well, let's step away from the textbook for a second and see how these calculations are actually hiding in plain sight all around us.
Here's a classic problem you might see. Imagine a horse is tied to a post, right in the corner of a big, square field. The rope is a certain length. How much grass can that horse actually reach to eat?
You see it, right? It's just a sector problem in disguise. The corner of the field is a perfect 90-degree angle, and the rope, well, that's our radius. The grazing area is just the area of a quarter circle, which you now know exactly how to calculate.
Or think about something you see every single time it rains, a car's windshield wiper. As it sweeps back and forth, it's clearing a very specific shape on the glass. What shape is that?
That's right, it's another sector. The blade's length is the radius, and the angle it sweeps through, which is often around 115 degrees, that's our theta. That clean patch of glass on your windshield is a perfect, real-world example of the area of a sector.
So, let's wrap this up. With these 3 essential tools in your toolkit, the area of a sector, the length of an arc, and that clever sector minus triangle trick for segments, you are now equipped to solve a huge range of problems.
We started with a simple slice of pizza, and we ended up with the tools to understand real-world stuff. So the next time you see a sprinkler, a clock face, or even a Ferris wheel, you'll see the hidden geometry. So my question for you is, now that you know what to look for, what will you discover next? Thanks for tuning in.